My name is Dov Ganchrow. I'm an industrial designer and lecturer at the Bezalel Academy of Art and Design. There are a few things that I'd like to talk about today, but I'm going to start by maybe just saying that I've always had this real keen interest in the way things are made. And I don't know if that's the reason I became a designer, but it certainly gives me a good reason to sort of poke and understand all kind of technologies and materials. And it's also sort of my in to this lecture today. I'm very happy we already had this sentence up, sort of looking at the definition of craft, because what I'd like to do is to start by sort of not diffusing the word hands, but expanding on the word hands. Because when we think about making things today, there are many, many different ways we make things. We do it skillfully, and we do it often with digital tools as well as our traditional tools. And so this would be sort of the traditional definition of a craftsperson would be an activity involving skill in making things by hand. And again, I'm going to be concentrating on the making things much more than on the hand. But if you think about it, even in the traditional sense, when we think about a craftsperson, it's usually an individual who has a certain material and a certain technology within which he works. So it could be like a blacksmith with his blacksmith tools, or it could be somebody doing scrimshaw or anything else. So often it's correlated, an individual is correlating his skills with physical tools that help him in creating those objects. So these tools, as far as I'm concerned, are sort of an expansion of our hands. So I think we can continue to call them hands, even though they're not physically or biologically part of our bodies. And if you think about it in other senses as well, I think if even again, traditionally sort of a workshop that perhaps produced artisan works, or an artist 300 years ago creating a giant mural, there were apprentices, and there were often a lot of hands working on a single work, which was often even signed by a single individual, but works of craft are often created by hands that are other than the hands, physical hands of the single individual. In addition to, if you sort of want to break it down even further, technically speaking, in the medical field today, we can take electrical impulses from our brains and directly manipulate a robotic arm. So even in lack, even if I didn't have arms, I could, in a sense, create things with my hands, because really what we're focusing on is the way we're thinking about creating objects and then the fabrication of these objects. We often think about this linearly. So we usually think about, okay, I'm thinking of a form, and then I create that form, or I make that form. It's true in the digital world as well. We often first have a digital file, and then have that file printed, created one way or another. It's not necessarily the case. There are instances where while we're working physically on something, that form is going to be changing as we're changing the way we think about it. But these are all sort of notions I'd like to sort of get out in the air before I bring us to two projects of mine, which I'm going to be talking about. So it's important to get a few ideas out here in the air. If we take, for example, a work by Dale Chihuly and Neri Oxman, two works that I chose to sort of juxtapose one next to each other because they're both sort of translucent, colorful, so have these sort of organic shapes. One is produced completely by hand, a glass artist. The other is produced completely on a computer and digitally printed. And both in some senses are very similar. And sort of I think outside of context or knowing who the person is who created these, I think often as individuals who are visiting a museum or walking down the street and spotting something, we don't necessarily know the difference. Even though, again, traditionally, the thought is that surely we'll be able to recognize something that's handmade versus something that's machine-made. But even in industry today, a lot of industry is sort of focused on trying to do mass customization, creating variations, and sort of the line becomes very blurry between what's manufactured and what's made by an individual in a single object. Another issue which I think has to be sort of tossed out in the air when talking about digital fabrication and making things is the issue of parametric design, where often a designer, an individual, instead of creating a form, is going to be creating guidelines for creating a form and creating an algorithm, which is going to either produce a single form or a series of forms, and in a lot of senses turns the creator into a curator in choosing what form of the forms presented to him by a computer is the desired form. This is a work, by the way, by Joris Larman, sort of a benchmark project in the field. And basically what it is, Joris Larman is a Dutch designer. And what he did was he took an algorithm that was created to mimic bone growth in the medical or scientific field and applied it into the design and furniture field. And sort of what it does is he can place a platform, say at 42 centimeters off the ground, and tell the computer, okay, I'm going to be applying 80 kilo of pressure to this surface, and the computer will grow a form that's going to mimic the way bone grows and gap that distance between the place you want to sit and the ground. And so he doesn't have direct control over the form, but he sort of knows where it's going. And one of the interesting things when you hear him talk about the project is also the way he does treat himself as a curator. And once he has a form, he'll decide, for instance, that the form doesn't look good enough. And so he'll tell the computer, okay, I don't want a leg in this area here. Please grow it again in a different direction, and until he's sort of satisfied with the form. And so it's this interesting thing about the idea of controlling form. And as people who make things, controlling form is sort of at the essence of what we're doing. Another interesting point I'd like to bring up is the value I think we often assign to objects that are made by hand and where we can recognize the amount of time invested in making them. There's something other than the examples I've brought are examples that are all geometrically complex and sort of we can have that sort of attachment or bewilderment at the complexity of these forms, but I think there's something deeper in our understanding. For instance, if we're walking around temple, this one was taken, I believe, in Amsterdam, in temple in New Delhi, where we literally can see the amount of hours, human hours, invested in making something. And next to it, a work by the German architect Michael Hansmeyer, who does this sort of, let's call them very complex geometric forms, which are completely generated by his computer and then later printed, 3D printed. They're complex maybe in a similar manner, and perhaps even the amount of time it takes a machine to manufacture them might be similar. And it's sort of an interesting question to ask whether we can assign value to something we know has taken a long time to be made, even though it's not human hours that have gone into it. It's computing hours or it's printing hours. And I couldn't resist bringing also a stalagmite cave, because I think it's something that, from prehistory we've sort of been amazed by, and I think it's not incidental that we often find prehistoric archaeological relics in these places. And again, complex forms, and again, at least today with the knowledge we have, we recognize the amount of time and the scale of time that it takes for these forms to be created. So the issue of time, I think, within objects is also an interesting question to ponder. From a completely different angle, when you think about digital tools that perhaps a craftsperson is using today, simply the way he gets his wares out to the world, markets them, sells them, is completely different. Websites like Etsy, where craftspeople all over the world can sell and share objects that they're making. Or if we, as far as I'm concerned, to sort of take it up a notch, a website like Shapeways, where if you're a jewelry maker and and you live in Singapore, you can upload a file of, say, a ring you've designed, and only once somebody's purchased that ring will that file be printed and sort of exist. It exists in the virtual world until it's purchased. And of course, as a business scheme, it's very interesting. We save tons of room. We don't have to store objects because they only exist once they're needed. I think on the financial level, it's also very interesting. You don't invest before you know that there's actually a consumer for what you're doing. And so it's a completely different way a craftsperson can get his works out to the world. If you take it up even a notch further, then we have situations where, for instance, we can bypass issues of geography, where somebody creating jewelry again in Singapore and somebody buying it in Berlin, it could be printed locally. the digital file is just floating out there, it printed locally, and then of course saving transportation, less greenhouse gases, et cetera, et cetera. So there are different ways in which the digital world is changing the way we're making things. I think I've said 3D printing about twice already, so I just to sort of level the plane a bit, say that the more popular term today is additive manufacturing, which basically encompasses tens of different technologies. And what these technologies do is that they take material, and like it's called, it's additive. They add material and to sort of create objects, and this is usually from a digital file, from a CAD file, either of something we've scanned or something we've created on CAD software. And basically speaking, there's sort of three large groups of technologies. One would act like a hot glue gun, where you have material that you heat up and then extrude and sort of build up layer by layer, sort of like an architectural map. Another would be working with powders, where you sinter the powders or bind them in some way in order to create level by level by level objects. And the other would be working with fluid polymers that are with UV light solidified. And today we see these technologies in metal, in sand, in various plastics, and so it's sort of across the board. Ceramics, printing technologies exist and are an integral part of the way we make things. And last slide before I'm sort of going to dive into a couple of projects is also the thought that often when we're working with these technologies, we aren't necessarily creating an end product. If you think about it as sort of a linear process, from the moment I think about something until the moment that it exists and somebody's using it in their home, there are lots of stages this thing goes through. And of course, there is the option, depending on the situation, of printing the actual thing. In this case, I brought an example of a lamp by a Belgian company, Materialize, printed in nylon and ready for sale, ready to be used. But on the other hand, I could perhaps print tools or print a jig or something that's going to help me make whatever it is I want to make. If you think a blacksmith traditionally often makes his own tools. And so the idea of somebody making the way they're going to make is also an integral part of the way we think. The image in the middle is 3D printed jewelry rings, in this case in wax, so that a jeweler can design a ring on his computer, print it in wax, and then later go through the traditional process of casting it in platinum or gold or anything else. And so sort of injecting yourself with the technology in some point along this process is also a notion that we should be aware of. So I'm diving into the first project I'm going to show you. It belongs to one of the territories in which I act, which is, it's called experimental design, design for speculation. It's projects that are usually singular, often don't have a client, or sort of either self-generated or generated from the outside to sort of create debate. In my professional life, I do anything from design medical equipment to museum exhibits to furniture, lighting, and so it's really across the board, also in scale and also in different kinds of markets. It could be plastic products that's for the kitchen that's produced in hundreds of thousands, and it could be a public statue for a municipality. So sort of bouncing back and forth, it's really all the same to me. It's all about understanding your brief and working with the correct technologies and materials per the needs of the project. So in this case, sort of question was put forth to several designers and ceramicists by the curators Maya Ben David and Jonathan Hope. The question was, what would ceramics industry look like in Israel today if it existed? Because we had sort of a booming ceramics industry here in the 60s and 70s. It slowly dried out in competition from China and Turkey. Today there's a single factory, that we can call it a factory, left. On global scale, it's quite medium, or small size of the medium. I'll show pictures from the factory in a second. And so I sort of asked myself, well, what would the legitimate business plan be? And sort of the thought was that a smaller scale, sort of like a large workshop, boutique kind of factory might be viable. Something that could be dynamic, change designs at a higher pace, target specific markets. And I approached it also as an industrial designer, thinking that instead of designing products for this imaginary factory, I'm going to design their tools. I'm going to design their molds. And here, again, I'm going to have to do a 60-second blitz, since I'm assuming most of the people in the audience aren't ceramicists, on understanding how ceramics ware are made. Most of the ceramics ware that you have in your homes, assuming you don't have a potter's wheel in your backyard, are made in a technique called slip casting, where basically you have a mold that's made out of plaster. You fill that mold with a material called slip, which is just very fluid ceramics. The longer the slip sits inside the cavity of the mold, the thicker the wall is going to be built up of the form inside, of the cavity inside. So that, for instance, if I'm casting a vase and I fill my mold to the top with slip and wait 5 minutes and then pour out the excess slip, I'm going to wind up, say, with a 3 millimeter wall thickness vase. If I leave it in longer, I'm going to have a thicker walled vase. It's part of the craft of knowing exactly what you're doing when you're making things. The plaster, what it does is absorbs the moisture, which is the reason the ceramic adheres to the sides of the cavity. And this is what it looks like in sort of a typical craftsman's shop would be creating a mold, creating a plaster mold like this. There are all kind of technical details that are needed. For instance, these are called keys, so that if assuming the mold is made out of more than a single part, when we put the parts together, they're going to align correctly. This is what it looks like in light industry, let's call it, filling molds with slip. And again, this was sort of my into the project. I was going to design a mold. This is a factory, the existing factory in Israel, Harsa studio in Be'er Sheva, that still work today. And I don't know, maybe the toilets here in Hansen House are showing their wares, I'm not sure. Now, one of the things also you need to realize when you're thinking about this, like I did it as a design brief, is that plaster molds are good for about 100 runs, and then they lose their effectiveness. Therefore, when you're making molds, you're going to be making more than a single mold. Often you want to cast simultaneously a whole bunch of toilets so that you don't your turnover time in the production is going to be much more efficient. And what all this means is that I need a mother mold to create molds, because if I need a lot of molds, I need a tool to create those molds. And so as far as my design process was considered, I had to do the exact same thing. So in order to get to this place where I have a plaster mold that's going to later cast a vase, it's a random form that's going to exemplify the idea of this process, I'm going to need to create a mother mold. This is what the mother mold looks like to begin with. And in this imaginary factory, I decided that the correct means of printing at least half of this mother mold is going to be 3D printing. For the reasons that I can change my design every other day. The variability is tremendous, because I can print something different, customized every time. I can have moving mechanical parts, in this case screws, for instance, because I can print moving parts, one adjacent to the other. It's one of the things that technology allows me. You can see the printed mold. The sort of these rigid rules that I set up for myself meant that this part is going to be 3D printed. It's also a relatively shallow part, and it holds within it only half of my design. If I'm making a vase, I'm making a concentric vase, and I only have half of the design here, because I'm going to be casting twice in my mother mold in order to get two halves that are identical and are going to fit one to each other in order to cast my plaster mold. I hope you're with me. This is sort of very technical, but it's also sort of the attitude. It's a sort of a very technical attitude that's creating also very functionalist forms. So the forms that are being created in the end are also forms that express this sort of very formal and functionalist attitude. So every little detail here sort of has a very strict logic behind it. The form itself is such that it'll sort of maximize or minimize the use of plaster. I'll be able to nest as many as I can because of this shape on the shelves in my studio. I have things like funnels for pouring the slip in and out. I have my integral keys, of course. I have places to put my bands around, codification, so that I can know what vase design is within the mold without having to open it up. So there's all them kind of little improvements, I hope, grasping areas that will make the workers' lives who are casting these things and working with them every day a lot more convenient. This is testing the process out. Because again, it's sort of like in experimental archaeology, where you go through the motions, you sort of have this theory, and to see whether the thing actually works. So getting the 3D print, casting parts of the mold, and then casting within the plaster mold all these vases. The sort of conical area on top doubles, other than as a funnel for putting the slip in, it also doubles as a guide for cutting the lip, the excess material of the slip away, which is going to give the finish to the open end of the design. I said before, so the chosen vase form is almost arbitrary, but again, I decided to inject a little bit of this functionalist thinking. So for instance, these decorative ribs that run around the perimeter are actually there in order to mask what we call the parting line, the place where the two halves of the mold meet, which is often sort of a blemish in products. We often recognize the quality of a product, be it injection molded plastic or be it ceramic, on the existence of a parting line, whether it was dealt with, whether the parts that created it were fitted well or not. And so you can see here the remnants of a parting line of material that sort of ran between the parts of the mold. And so here we have something that's sort of functional decoratively, but the reasoning behind it is a very functional sort of reason. This is what they look like after glaze. And again, this was the focus. I'm moving on now to the last project I'm going to show, which was started quite a few years ago with my late studio partner, Ami Drach. It's a project that's been going on for several years now and has different chapters to it, all dealing with prehistoric stone tools. I'm going to only show one chapter of this project, but I think it's a chapter that fits the theme well. These are hand axes, napped in flint. I napped them myself. Napping is the prehistoric technique, maybe our oldest craft. It's certainly the oldest craft we have proof that existed. Roughly 2.5 million years of experience in napping. The technique itself is pretty simple, pretty straightforward. Has several different variations to it. On the left is sort of direct napping. Basically, you just hit one stone with another, or you hit it with a bone, or you hit it with an antler in order to create controlled breakage. On the right is what we call pressure flaking, where we've taken one of the flakes and now we're applying pressure with a bone again or some tool to the edge of the material to break off small chips. So, for instance, if I'm creating an arrowhead, I'm going to be using this pressure flaking technique, but I actually prefer working in direct napping and just sort of slamming one stone against each other is somehow very satisfying. It also, I think, creates very interesting forms and that are immediately recognizable, certainly to any archaeologist. This sort of shockwave that's traveling through the material and creating scarring or creating some sort of remnants of the way this object was made. It's the way today when I walk around the hills just outside here, I can tell the difference between a broken stone and a stone that somebody broke on purpose. And the second you begin to read these codes, it's a revelation as to how many tools or parts of tools are laying around us from tens of thousands of years ago. Now I sort of always knew about this technique, but my hands-on introduction to the technique happened at an event we hold once a year with the Industrial Design Department at Bezalel, which is basically a workshop we do at the Dead Sea. We sort of, it's a forced vacation on our students. We sort of in the middle of the semester tell everybody, drop everything you have in your hands, leave your laptops at home. We're all going to camp for a couple of days on the shores of the Dead Sea, and we have a series of workshops that change from year to year, but there's a core that sort of remains the same. It could be basket weaving, it could be metal smithing, woodworking, and the students sort of roam freely between these workshops and create things with no proper objective, certainly in the traditional academic sense, but they get a whole lot out of it. And as far as I'm concerned, this is what triggered for me this project, which again has been going on for several years. So initially we had a young archaeologist teach how to nap, sort of very basic technique. I later found myself, just when hiking, picking up stones and trying this technique to, how you can hit a stone with another stone within, 2-3 moves. You have something that's sharp enough to cut grass with, or some other organic material. And I also discovered, and this is also an interesting thought regarding craft, I found myself watching YouTube tutorial videos on napping late at night, it's just this tremendous, no matter what it is you're interested in making or how you're interested in making, this tremendous amount of knowledge that's floating out there. And I don't think it replaces, having first-hand experience, but it certainly shortcuts a lot of, you can learn a lot by looking at other people napping. There are interesting experiments within the archaeological field on perhaps how knowledge was transferred, and we're talking over in evolutionary terms, before we know we had development of language, whether mimicking, watching, having somebody instruct, verbally instructing, how this knowledge is passed on from generation to generation or from individual to individual. Another great thing that happened because of this project is that I had a really good excuse to go hiking all the time. Because I needed raw material to nap. The chosen material, certainly in this area, is flint. It's a very hard sediment rock. Further north from here, we have materials like obsidian, which is volcanic glass, which is even better, but absolutely superb material to work with. And sort of maybe as a side story, at the Israel Museum here, there's a core that blades were chipped off of that was found in a dig here in Israel that's 10,000 years old, made out of obsidian, its origins of which are somewhere around Anatolia, Armenia. So 10,000 years ago, it was an important enough material for somebody to carry it all the way down here to create blades for trade or for use, whatever. So it's an interesting material. This is what it looks like when I find it, raw material. I'm of course very concerned with the quality, were there any inclusions in the stone, what the size of the physical stone is. It's going to be comfortable to work with, but it usually works, and you get an eye for the right material. At some point, I had sort of amassed on my table tons of these semi-prehistoric looking tools, and my ability to create these tools became much better. And without being able to say exactly why, since again there was no deadline, no client, no brief, we decided that we were going to start making works out of these tools. And the first thing we did was we took them to the Hebrew University here and had them scanned at Professor Leo Grossman's digital lab. They scan artifacts there all day. It's part of what they do. They do it for research purpose, of course. So they're sort of looking like a detective looks at something, evaluating it, understanding its center of mass, signs of use, etc. So that there's very serious academic work being done on it. For us, the act of scanning three-dimensionally was just a tool to continue to create. It wasn't looking backwards, but rather was looking forwards. And so the second we had digital files of the tools, what we could do is we could treat them the way we treat a medical product, for instance, that we're working on, and continue to develop handles and ways of handling these objects in our CAD systems. Eventually, these parts got 3D printed, both by Stratasys, by Objet, and later by Aran. And so what we have here is an example before assembly of what the part looks like. So we can create an exact negative of the space because it looks like it's cast on the material, but it's actually just imprinted digitally on the file, since we have the topography of the object as digital information, and we can use that both as a positive and as a negative to create sort of absolute fit between parts. And of course it allows us to sort of create this conversation also between forms and also between technologies, sort of the stone being sort of a found object, a given form, and sort of the decision of how another form is going to meet that form, both technically and visually. And of course, if it's something that has to be handled, then it takes all the issue of ergonomics into it. This object here is sort of it's the beginning of a conversation about industrialization of this thought of making things that are very, very customized on the one hand. But in this case, what we did is we have these two spacers. The gray parts are spacers that fit absolutely to the stone, but the handle, in a sense, is a handle that could accept many different stones or many different stone blades within a given geometric constraints. So that perhaps a longer blade or a fatter blade, so long as we could continue printing spacers, we could continue using the exterior shell. So this is sort of the beginning of an industrialization thought on something that's very, very customized. And this is the last image I'm going to end with. So the first group of stones, and again, there were several chapters to this project, but I think this image sort of embodies the way these two technologies meet each other, these two materials meet each other, and they're both, it's both about making, it's all about making things. Thank you.
What did it feel like to make a shape like this that you know that's been made for the last 2 million years?
Okay, that's actually a good question. I can take a minute and talk about this specific form, which I sort of became obsessed with over time. It's a sort of teardrop form or almond-shaped form, and it's sort of the iconic Handaxe, which is probably the most popular tool that hominins have had ever, in the sense that it's found on almost every continent and over a period of hundreds of thousands of years. We sort of don't have any example of anything so specific that was used over such a long period of time. And as such, within the archaeological, philosophical, and other communities, there are a lot of questions and theories that are raised regarding this form. I'll rattle off just a few of them because, again, I'm fascinated with this form. There's one theory that was brought forth that, for instance, I have to start and say that that generally this form is considered something that isn't connected to a handle, but rather is handled directly. And that it's considered sort of a multi-tool, something that can do many, many different things. It has a sharp point, so you can use all that mass if you need to get all your force into a single point. It has longer edges, blades, if you need to be cutting something. So it's sort of the thought is, the assumption is that it was a multi-tool. But again, the farther back we go, the less, or the more difficult it is to prove things, which leaves room for all these interesting theories to spring up. So for instance, one of the theories is that it's a mating object. That why is it a mating object? For several reasons. One is archaeologically, these forms have become over time more and more symmetrical, which doesn't necessarily have anything to do with the way they were used, because apparently they worked good enough earlier on than to their later forms. And some oversized hand axes have been found, which sort of raises the question, if I can't hold them with one hand or maybe even with two hands, what are they used for? And when you think about it in an evolutionary term, in order to make a hand axe, you need good dexterity. You need to be able to find good materials. If you can make tools, you're probably going to be able to create shelters, hunt with those tools. And so basically they're expressing, you need to be able to plan ahead several stages. It's not a very direct action. And they're all traits that we still have today. So in some senses, it may have been something that symbolized individuals' abilities and traits, which again, genetically get handed down. So that's one of the interesting thoughts about this teardrop form. There are theories that it was used, for instance, as a projectile, that it was actually thrown as a disc for hunting, and as such didn't have a handle on it. As a designer, it raises interesting questions, because there's a sort of, often there's this sharp perimeter all around. And you sort of say, if it's something that's going to be handled, why would I want a sharp perimeter all the way around? And so there's the thought that perhaps it was halved for a moment, like the way I pick up my teapot when out of the bonfire, I take my cap and hold it for a second so I don't get burned. So maybe I had a piece of leather I could temporarily hold the tool with, depending on what side I was working with. So there's all these interesting questions, but when you think about this form, you know, diamond rings still retain that form. There's something about the form that we continue to see beauty in, the symmetry, and we continue to see in different places in our lives. It's maybe an aerodynamic form, something that looks very correct. So that's something about the form.